Then we need to figure out if someone won. To test with this, we can create a dummy. Just an array we define ourselves so that we can test if our certain situations work. I'll make it a Boolean array because that's what we can do logic with. So to figure out if a row is filled, which means someone won, because fitting a row, fitting a diagonal, or fitting a column means he won. That's quite easy. You just take the dummy and you do end fold over the major cells, which means the major cells in this case are the rows, because that's one dimension less than the 2x2 array. We're doing an end fold over that, which means are they all true? Are they all 1? And if we will print this, it'll give us the results of each row. So this one is not all 1, this one is, and this one isn't. So if we were to give this a 1, for example, it'll still return 0 because they're not all 1. And then what we want to do is OR fold. So we're going to take this list and then see if one of them is true, which means there is one row which is true. And then we already get our Boolean saying that there is one of the rows is true. So that's how you get a correct row. Then if you want to do the columns, all you want to do is transpose the dummy, because transposing it, you just delete this, we'll just take the array and rotate it like that. Oh wait, yeah. So the x-axis becomes the y-axis and the y-axis becomes the x-axis, which means all the columns become rows. So if you were to do the same logic with that, you would get if there's a column all true, so now that's true. And then we want to do this for both the rows and the columns, because we want to check both. A cool way I found to do that is to enclose this, so you make it a toTrain, and then to do the after operator, and then here OR them with an O at top. And we can see if we run it, this will work. So the column is true, and what's going on here is these modifiers are applied from left to right. So this forms a function first, and then this is attached to that function. So if you run this parameter is going to go into this function and also be given to the left of this whole function, which means the right argument is going to be the transformed version of the dummy, the transposed version, and the left argument is just going to be the dummy without any transformation. Then this function is composed so that the left and right argument are passed separately into this function. That's what the top does. Oh, or what the over does. It's over if you call it dialectically. And those are passed as left and right arguments, the results, to this function. So we get a transposed version and the normal version, which we run through this function, which you'll get if there is a row filled. And then we OR them both together, which means it's one or the other true. And that means that we get both cases, if that makes any sense. Okay, and then we want to find the diagonals. To get a diagonal, you just need to do rotate on 0, 0 axis. It's a bit hard to understand why. You can read the documentation. But there is some logic to it where if you get the 0, 0 index or axis, or then you get the diagonal. Don't ask me why. And if you were to do this in the dummy, let's move it up. You would get a snapshot of the whole diagonal. So 1, 1, 0 is what you get back here, 1, 1, 0. And what we want to know is if they're all true. So we just fold and fold over it, so we get if they're all true. That's not the case now, and if we were to fill this one, that is the case. So this is going to be our function to get a diagonal, but only the diagonal from the top left to the bottom right. If we want to get the other one as well, we cannot use rotate because the diagonals stay the same because they're mirrored exactly. So what we would need to do is to rotate the whole thing, because the rotated version is going to make sure that everything that's here is going to be there. So it's going to flip it like that. And that will give us the other diagonal in that same position. And then the rest is the same as the other function. We want the rotated version and the non-rotated version, run it through the function, and then OR them together. So here we have two functions, which this one gets the diagonal, and this one gets the horizontal. Which is what we want to see if someone won. And then we just make a bigger function called 1. And this one needs to work on a character array, the 3x3 character array. So we can delete the dummy. Let's just parse in the character we want to check that if it won, and the field. We will transform this field which has all these characters in it to a Boolean array. So for example, if we take the field and we do equals and then the character, if you were to show this and run this function with a field with the character, that character, and if you run this, then you get back, I'm just running this script, then you get back this Boolean array with all ones because they're all matching this character. And if I will give another character, like the computer character, this is referring to this character, it will be all zeros. And if we were to fill this with empty and computer, this would generate this type of field. So first one and the other, then one and the other. And we check this. It'll give us back this array because this one is matching, this one isn't. So we get a Boolean array from the matching character. We want to give this Boolean array to both horizontal and diagonal, and we can create a nice train for this. Just type in horizontal or diagonal, diagonal. And that should give us back a Boolean. If we show this, if either one is correct, so if there's a horizontal or diagonal. This works because we have a toTrain where the argument, this Boolean array, is given to the left function and the right function, and then the results are passed as a left and right argument to this function. So we're just doing both functions and then ORing them together. And that's how we get to see who won. Okay, perfect.